Hi there, thanks for joining me for another episode of Mr. Ed Codes. And in this episode, I'm going to be continuing my look at classic arcade graphics done in modern programming language, in this case p5.js. I'm creating a brick tower object. This object is really versatile, really robust. You can make it different size, you can scale it, you can move it around, you can have different properties and attributes and use those in lots of different ways. So I want to go through how this object is constructed, what are the procedures, and then I'll go through the code line for line, and you guys can type it along as I'm going through, and I'll explain to you what all of that does. And then I'm going to change some of the variables as we go along so that you can actively see what changing this will do to the output. So let's get started with that. In the window here, you can see we have 3 towers that are lined up, and every once in a while they'll change their appearance. All of that is done in Draw. So if you want to change this tower, if you want to customize it and do stuff with it, you're going to do that in Draw just by changing the tower's parameters and how it's being drawn, I guess. But everything else is in the function. It pretty much does its own thing inside the function, and it's pretty independent, so you can do a lot with just these few parameters. I'm going to go down here through the program. So I'm going to change some of the output for some of the settings for the draw in this before I go through and explain what it's all doing. I just want you to see how this object can be used in different ways. So right now it's being lined up contiguously on the screen. So I have tower 1, 2, and 3 lined up from left to right, and they are matching one another. That's because their size is always the same. So if I change the size, if I change this parameter here, so you can see for these 2 variables right here, it's the same variable, but I'm setting it to a random number first, and then I'm setting it to 10. So I'm going to just take that line out, and now the random number that gets picked is going to fall through. It's not going to get reset to that static value. Let's see what happens. Now we're getting different level sizes. So the bricks are scaled the same. I think it's still the same scale. Are they smaller? Yeah, the bricks are getting smaller. Okay, so yep, it's doing what it's supposed to be doing. So it's still printing them contiguously, but since their scales are different, they're misaligned. Something to keep in mind in how you generate the output. So let's move them across the screen. It just so happens that I have a variable here that's associated with each one of the tower's position. So now I can change the position of each tower over time, and we get to see what that looks like. So I can change the scale, I can change the position, I can change how they're laid out according to their position in the array. So they have a contiguous position based on their element number, their index number. So here when they get to the end of the screen, to the edge of the screen, they're reprinted and given new properties, and they look different, and the bricks are different size. And okay, so that's a little bit of how the output can be made to look differently and how robust and versatile this object is. So let's look at what makes this object. When I was first starting out trying to think of how I'm going to do this in code, I had to think of how I was going to do it in procedures. What are the procedures for making a tower? Or at least what could be some procedures? This isn't the only way for making a tower. There are other ways to make a tower. This just happens to be the way I came up with. And it probably I'm absolutely certain somebody came up with it before I did. So I'm not like king originality here. I do kind of want to stress that when you are reductive in this manner, you can really start to see what kind of code you need. So let's look at what we're doing here. We need a brick, and I want that brick to be changeable. So I want to be able to change the scale of the brick, I want to be able to change its color, and I want to be able to change its shape a little bit, make the edges rounded or sharp. Next, I want to be able to place those down in a certain order to create a tower. So if I was going to draw this on a piece of paper, I'd have to look at the piece of paper and go, okay, where is this tower going to start at? Well, I'm going to start at the bottom of the piece of the paper. So imagine the paper is your canvas, you're starting at the bottom. But I want that location to be anywhere on the screen. But in theory, whenever I'm starting out building a castle or building a tower, I'm going to start out on the ground. I'm not going to start out in midair. So just keep that in mind. We're starting out on the ground floor. So when we build a tower, we're going to build it from the ground up. And that's what we're doing here. You can see on the right-hand side how we lay down bricks. The very first thing I do is lay down a long tower-wide rectangle. And then over the top of that, I'll lay down 9 bricks or 10 bricks, depending on whether or not the bricks need offset, because we want these blocks to line up in a brick pattern, which is, it's offset a little bit. We know how brick patterns are, right? So in order to do that, I need to keep track of the floors. If I'm on an even floor, then I want to handle it one way. If I'm on an odd floor, I want to handle it another. And where I have like 9 bricks, there's going to be edges. The edges, there's edge case there, where there's half bricks. I don't want to make half bricks. So in order to cover that area with some kind of brick-looking graphic, I just make a tower wide brick and set it behind. So now I have one solid brick that will cover all of the area. And then if I want to make all the other bricks look like bricks, I just put them over the top. And wherever there's not a brick, it looks like a half brick. Does that make sense? You can kind of see it here a little bit in the graphic. And bricks are offset by half of a brick's width. So that's kind of how bricks are, or the floors are made. And then I just repeat that process going up to however many this dot tall. It could be 14 levels, 10 levels, 5 levels, 8 levels, whatever you want there. So once I have my bricks stacked, I need to do something with them. So as I'm building the tower going up, I'm going to count the floors. And if I'm at a multiple of a certain number, this frequency value, if I'm on that multiple, then I'm going to put a window on that level. And where am I going to put that window? I can randomly put it there, or I could just increment the position, and then when I get to the edge of the tower, start back over at the left hand side and just keep doing that all the way up, and it'll look like the windows are spiraling around. So either way, it could be handled. How I get the range for where I'm dropping a window is based on where a brick goes. So it's always going to be a factor of a brick's width, and I want it to be a brick and a half or a couple bricks away from the left hand edge of the tower and the right hand edge of the tower. And depending on which row, if it's on an offset row or a flush row, that's going to be slightly different by a half a brick. So keep that in mind. But it's spiraling around, and we'll see that here in a little bit. At the very top of the tower, I put my battlements. The way that that's broken up, I have 7 battlements. I have total of 10 brick positions. So if I have 7 battlements, that's going to leave me 3 bricks width of space that I can use to space these out. So I'm going to take that 3 bricks width, divide that by 2 so that I can get 6 half bricks. So each one of these battlements is spaced by a half a brick. So I have 7 whole bricks, 3 brick spaces divided in half into 6 half brick spaces. That makes all of my 10 bricks. So everything's nice and flush on one side to the other. Now, I can do this with 3 bricks or 5 bricks or any number of bricks less than the number of bricks wide a tower is. And you ideally want at least 3, 1 on each edge and 1 in the center. So kind of working in that range is how you get your battlements to work out. I just arbitrarily selected 7 because I thought it looked, and it was easy to work with half bricks. So I'm just going to walk through this code line for line and explain what's going on. And from time to time, we're going to look at we're going to adjust some variables so that you can see in real time what that does to the output. If we change number of towers to 2, that's really easy to predict. We'll change it to 1. That's really easy to predict. Here we have just 1 tower now. So that lets you know what that's doing. the show stats, that's the text. That's the text over here. And M tower, that's move tower. So each one of these towers has a movement value associated with it that's stored in an array. And there's a constant rate. So this rate is constant because it's going to be a proportion of that tower's width at scale. You'll notice that the larger towers, the larger scaled towers move faster, and the smaller scaled towers move smaller. And that's because you can fit more smaller ones across the screen, more multiples of them across the screen than you can larger ones. And the movement rate is a factor of that. So that's how you get that. An interesting side effect is that it causes some parallax. So larger scaled objects move faster, as they would because they're closer to you, and then the smaller scaled ones move slower. So as long as you print the small ones behind the larger ones, that effect is really going to come through. It fades away whenever the small ones are moving, moving fast in front of a large one. We can affect what our range of our tower height is. So it's going to be at least 8 floors tall and no more than 45 floors tall. So just changing those would affect that. I think you guys can imagine what's going to happen there if we do that. So let's stop this and look at our setup. Is that all the variables in there? I guess there wasn't a lot of global variables, so that's good. So in setup, we're just doing a loop where we're going to instantiate through the number of towers we have this function here, which is building. We're going to drop down and see that here in a little bit. And building can accept some parameters, and those are the scale of this object, the tower, its minimum size, its maximum size, and then the frequency of how windows appear as we go up the tower. After we instantiate that, we want to make that tower. So we're going to do the math calculations. We're going to add the random colors and whatever to each tower in setup when we instantiate it. So when we're ready to draw that object, we're going to get a static set of values that aren't going to change every time we call the function. The next thing we're going to do is put the movement value into an array, and we're going to start out moving at 0. So we're at the left-hand side of the screen. This number here, whatever number is in there, it's going to be a small number. Somewhere at most might be 8, 9, or 10. And that is going to equal a position on the screen. So if I made this 3 and played this, our tower should start out somewhere around the center. And there they are starting out the center. If I make this a 2, they're going to be a little bit closer to the left when they start out. And a 1. There you go. What that allows us to do is if you're printing them one element at a time, all you have to do is pass the element into the function, and it's going to automatically figure out where it needs to be printed on the screen in order for it to line up and fit together seamlessly. That's a really handy and robust feature, I thought, and it took a little bit of time to get that to work out, but it did. And then after we drop out of that, so here's the whole loop. Once we get out of that, we're going to show that text if you want to. I mean, that's optional for you. All right, now that's the end of setup. Here's draw. I set the background to blue. You guys could see that. I want to show my text, and then my towers can move over the top of my text, so it's not going to obscure the towers. Then I'm going to run through a loop. That's however many towers we have. And the very first thing I'm going to do is move a tower. That's what I'm doing here. I'm taking that movement value that's associated to whatever tower that's in the array, and I'm moving it by that constant value there. Then I'm going to check and see if I've moved it off the screen. And that comparison isn't to the width, the actual width of the screen. Rather, it's an integral of the width. So I'm going to take the width and I'm going to divide it by however wide the tower is. And that's going to tell me how to move. And it's also going to tell me if I'm off the screen. I guess I should have said that first. If it is off the screen, I'm going to set it back to the left by resetting that movement value to 0. Or I could set it to the center or wherever I want. That's what I'm going to do it right there. Next, I'm going to change all of the attributes, the properties, like how big is the scale of this thing, how tall is it in floors, how wide is it. Now that's not adjustable, that's a constant variable here, and I did that because I didn't want to have to refigure the number of battlements that I could fit on any given width of tower in bricks. It's a whole other set of calculations, and for simplicity's sake I just left it out. It's not so important. If you want a tower that's wider than 10 bricks, then make 2 towers and put them together in whatever number of bricks that you need. See how that works? It might be a little wasteful that way, but you know, for now that's the way it is, and I might work on that later. And then I'm going to adjust the colors so that we get a random color building within a shade group every time. So this is biased toward red. You can see here it's more heavily red than it is green or blue. So overwhelmingly the shade of these castles are going to be somewhere in the pink, beigey area. Occasionally they'll be red brick colored, but most of the time they're going to be mostly pink, which I'm not crazy about. So just mess with these if you want, and you can change the tower colors. Once you have all those new attributes assigned, then we have to make a new tower based on those new assignments. So we're going to do all the calculation in math to make a new tower right here in this part of the function. We're going to drop out of that condition, then we're going to drop out of that loop. So here is the whole run through the towers loop right there. Here's that condition. Right there is the condition. So if it's off the screen, do all this stuff. If it's on the screen or off the screen, we're going to move it first and then handle that. The next thing we're going to do is move through our array to display our tower. Could I have done this up here? Yeah, I sure could, and probably should do it up there. And I don't know why I didn't. Let me move this around and see if that works. You know, I think I was afraid that I wanted to make them all, then I wanted to display them all. But so long as one is made, then I can display it. So it's okay to move this right up here. So I'm going to do that for efficiency's sake. And I'm going to take this other extra loop out because I don't think I need that. I'm pretty sure I don't. This will still work, maybe-ish. Oh, it needs to be outside that loop. Or outside that condition. So here's my condition. I'm still inside the loop going through the towers right here. So before we all have a seizure, let me hit play on that. So it's working. It is working that way. I don't need that extra loop. Sometimes explaining things to yourself or to an invisible audience that may or may not be there helps. So we're done displaying it. We're done looping through it. We're at the end of draw. Now we're ready to do our function that actually builds a castle. I'm going to open this up because some of these lines are long. Because this is so robust and versatile, I keep using those words, most of the accounting for anything else that we need in the world is going to be done as much as I can inside the function. So there's a lot of variables that are inside the function, and then I have a few 4 variables that are passed into the function whenever we instantiate it. And then I have another variable that's passed into a method when we call that method. So what are the first things that we need to look at? It's the parameters of this function. We've got its scale size here, its minimum height, its maximum height, and the frequency of the windows. Just like when we instantiated and passed those variables in, they're receiving, the values are being received by these variable names here, and they're arbitrary. Just so long as what you use here, you use down here in the body of your function. Let's look at these variables that we're using when we instantiate our object. We've got its size that comes from the parameters. We have its height, which comes from the parameters, a minimum and maximum value. we have its width, which is set to this constant of 10 bricks. So a tower will always be 10 bricks wide, no matter what. You can change this if you want and play around with it, but I promise you it's going to cause some problems. There's a value here that's kind of labeled weird, so I'm going to annotate this just so we can keep it straight in our head. This value here is the offset. So I'm going to assign to this variable, this dot brick, I'm going to assign to it either 0 or half the width of a brick. And then I'm going to add it to the position that I drop a brick at. So no matter what floor I'm on, as long as I'm on an even floor or an odd floor, I can change that brick shade value to its even setting or its odd setting, so those bricks will be positioned correctly. Brick shade, that's holding the color, biased color, which in this case is red. There's weird effects that happen when you start messing around with the colors and the color settings that are kind of interesting, so I encourage you to just play around with that, go crazy, and try to make bricks as crazy colored as you want. It'd be really fun. And I give you one array variable to do that with. If you want to set up 3, 1 for each red, blue, and green, be my guest. This is how it's done. The shape of the brick is held in this array here, and it's called sharp for sharp edges or for round, flat edges. I didn't want to call it shape because I have a problem with characters that look the same. And my brain will rotate letters. When I see letters and stuff, they just go in my brain, and my brain doesn't really care what orientation they're in. That's bad because some letters are different depending on which they're oriented. You can see the difference between a D and a P. The good thing about this, the superpower, if you will, it's easy for me to manipulate shapes in my head. I can visualize an object and I can rotate it and change its size and do that all with my imagination with pretty good fidelity. And it's because my brain is automatically doing that I can do it. It's not something I've really exercised or tried to do. But the downfall of that is I will do that to letters and numbers. So I have a hard time with E and 3, 6, 9, P, D, Q's sometimes, B's. It's just a nightmare the way things are written. They're not really helping me because if you rotate them, they're completely different. But anyway, if I keep this in here, you got a dose of that. Otherwise, let's continue. The next value is brick number. I want to annotate this with what it represents, and it's counting the elements. And what elements? The brick elements. There we go, brick elements. This variable is counting the brick elements. So every time we drop a brick, we increment this, and then we can keep track of, is this brick number 0? Is this brick number 25? Is this brick number 412? If it is, then give it color 400, give it the color associated with that one, give it the shape associated with that one. See how that works? Then once we start over building a tower, we just reset that value back down to its starting place, which is a little weird. We'll talk about that here in a second. Our windows or our lookouts, that's held in an array. And it's going to, a value is going to be pushed into there on whatever relevant floor that's related to the frequency value that we pass through right here. So how do we know what its frequency value is whenever we're going through our loop? We're going to keep track of that in this lookout spacing. How far is the spacing between the lookouts? That's going to be held in this variable here. We need a variable to hold a random lookout number. In the example that I have here, I wrap the windows around in a spiral, but you could have them randomly positioned if you want. And this variable will hold that random value if you so choose to use it. And then I have a variable that holds the red, green, and blue shades, and it's biased here in this value toward red. And then I need a value that will hold our X offset. So as I'm moving this across the screen, I need to add to the origin of our castle whatever its position is on the X axis, and that's what I use this for. The ground floor is constant in this example. It's the height of the canvas. So I'm starting at the bottom of the screen. But if I wanted to, I could change this as well. So I have a variable that will handle the y. So this is actually the x origin, or the x plus x origin. And this would be the y plus y origin. Be sure to annotate that, or I'm going to throw an error. So just so you can keep that straight, wherever we need to move our castle to, we're going to change this value to that. And I think build on, it uses the index value and the width of an object to figure out where it needs to be printed. So remember that this isn't going to be like, if I want to set it to the center, I'm not going to be able to type width divided by 2 and expect that my castle is going to be at the center of the screen, because that's just not going to happen. It's an index value, an integral of its width. This.make is our first method in this function, and this is where we do all the math that handles how to make a castle in terms of its color, its shape, and its positions of bricks. The very first part of that is to look at the arrays and see if they're empty. If they're not empty, we want to empty them, because if we start pushing values into an array that already has values in it, we're not going to be able to use those new values. We're going to be using the old values instead, unless we move the index value up to the end of that new group. But then you have an array that goes 10 miles long. It's best to just splice out all of those elements and start with a fresh array. So that's what we're doing here. When we first start, the very first time, there are no values in the array, so it would pass through this. Everything's okay. But then once you've made your first castle, those arrays all have values in them. So then you need to look and see, okay, they do have values in them. Let's erase them. And I only test for one array, but I erase all 3 arrays if this is true. Assuredly, if one of the arrays has values in them, all of them have values in them. So if one of them has a length, then you can erase all of the arrays and not worry about it. So that's what we do there. Then we're going to go into a loop that's going to go from floor to floor. That's so we can look at, see how our bricks are offset, and also where to put a lookout. In order to do that, we need to test the floor to floor, odd floor, even floor condition. So we're going to take I divide by 2. If it equals its integer value, then we know that it's an even number. So if it is, then we're not going to offset any. So the ground floor is flush. The next floor is offset. The floor after that is flush, and so on and so forth, all the way up to the top of the tower. If we need the brick to be offset, we're going to take the width of a brick, which is in this value here, this dot level. We're going to take the width of a brick and we're going to multiply it times half. And that's going to give us a half brick's width. So there'll be a half a brick on one end. We're going to print not 10 bricks now, we're going to print 9 bricks. So that at the end of that series, there'll be another space where there's a half brick missing. Those are our edge cases. And then the tower wide brick is behind those, and that's going to make the appearance that there's half bricks there. Once we get done with that condition and we've determined what our offset is going to be or not be, we have this choice here. I annotated out this line because I put in this. So this part right here is going to increment our window position. So every time we go up to the next frequency where a window goes, we're going to move over a set amount, and we're going to keep doing that until we get off the tower, and then we're going to reset to the left side of the tower and just continue all the way up. It's going to create a spiral. If you don't want a spiral, if you just want random numbers, random positions, then just comment out this if condition, restore this one, and it will do the random one. Once we figured out whether or not a window goes on this floor, if that condition is true, we want to assign to a local variable what our vectored variable is going to be. So what I'm going to do is take the lookout position where our window is supposed to be. I'm going to assign its coordinates to a vector to make it easier to work with. And it's going to give me a .x and .y for that. So I use these local variables, vx for vector x, vy for vector y, and then I'm going to assign to that where I want that x, the x of that window to be, which is going to be a multiple of whatever that incrementing value is, and then it's going to be a multiple of how wide the tower is divided by how big a brick is. And then that's going to give you the right position that it needs to be in. And then I just want to put it on the ground, put it on whatever floor it's supposed to be on. Once I've figured out what my vector values are going to be, then I can push that value into the lookout array, and that's what I do here. This .lookout.push, inside the parameters I have the create vector, and then inside the create vector I have the vx and the vy. Once you've figured out where your windows go, the next thing you want to do is figure out what's going to go on with your bricks. They need a shape and they need a color, so that when I draw them I have these values available. I'm not trying to find these values while I'm trying to draw them, because what will happen is if you have anything that's random, it's going to show up in the drawing every time you draw it. So it's going to flicker and do all kinds of weird stuff and be all spastic. To avoid that, we're going to set up the math for it, and then we're going to display it in a separate method. So that's what we're doing here. We're looping through all of our bricks. We're putting our random value for the shape of a brick and the random value for the color of a brick. We're putting that inside the array. We're pushing it into the next element in that array. We're going to do that for every brick. Once we're done, we're going to take the lookout from up here. So we've kind of maybe, I could probably put this up there and it would be in order. But in terms of how the program's operating, it doesn't matter. In terms of understanding how the program operates, it might matter. So when I'm doing my window thing, once I've figured out where a window goes, I know that there will always be a window on the 0 floor, because that's an integer when you divide it. It works out to be an integer. I don't want the window to be on the ground floor. I want a door to be there. But I have this window location available to me. So, or at least I have this lookout element in the array available to me. So I'm going to use that element 0, where there would be a window. Now I'm just going to set this value to the center of the tower. And I have to make that an integer, because that's a position of a brick. And the brick positions are in integers. Like brick 0, brick 1, brick 2, brick 3. They know where they're at on the floor by what number brick they are. It's kind of how a castle knows where it's at on the screen, by how wide it is. Sort of. So I'm going to use integers here. And then inside that floor, this gets a little bit extra. But I'm dividing the width of the castle by the width of a brick, and then I'm dividing the width of a brick in half, or dividing that in half. So I get that center of the castle. Did that make sense? Did I just make that worse by explaining it out loud? And since a door is 2 bricks, or 2 stones wide, 2 bricks wide, I factor that in there too with this -1. I think it's 2 or 3 wide. It might be 3 wide. Whatever it is wide. This formula, all of this right here, is going to make your door, where your door location is. Okay, I'm outside of my brick making loop. I'm done making bricks. The very last thing I want to do is this right here. Do I want to? Why am I doing it out here? I don't think I need this. Let's take that out and let's look at what happened. I don't believe that's important. I don't think it should be there. Okay, I'm not sure why that's there, why that was there. But yay me, going through this for the 5th time and finding still more things that shouldn't be there. But take that out, because we're doing that right here. That might have been a holdover from when this wasn't completely made yet. That might have been it. I'd hate to speculate. But anyway, once we're done figuring where the door is, we end our loop, then we end that method. So we're at the end of our this.make function. Now we're going to make another function, another method, this.display. In the parameters of that function, we're going to pass in the index value, and we're going to call it nth, so we know which one of these towers we're on. The very first thing we're going to do is find out where we're going to print this tower at. So we're using its index value, we're multiplying times how wide it is, and that's going to tell us where it's going to go on the canvas. I know it doesn't sound like it is, but trust me, it does. Then let's encapsulate all of our graphics with push and pop. We're going to set the rect mode to corners. I could have worked with the center, but just conceptually it seemed easier if I just draw a rectangle. Instead of working with radiuses, widths, and stuff like that, I just want to find the lower left-hand position, find the upper right-hand position, and draw a rectangle that size. We want the stroke of the very first stroke pertains to the tower wide brick. The color is going to be inverse to a brick's color so that it shows up better. I wanted high contrast there. The stroke weight is going to be 10% of a brick's width. So if a tower is 10 bricks wide and a brick is 1/10 of that width, the stroke weight is going to be 1/10 of a brick width. So it's all in proportion. And that's what's happening here. I want to set my brick number that's counting the elements in this brick array. I want to set it to -1. When I start incrementing it, I want the first value that I increment to be 0. So that's why I'm starting at -1 here. Then I'm going to loop through each floor. The very first fill is going to be for the tower wide rectangle that's in the back. So I adjusted the colors a little bit here so I can get a darker shading on that back, or at least a contrast shading on that back rectangle. And then the edge cases show up really well, and you get this neat effect on the side of the castles. Once I have the fill and the stroke, I draw my rectangle. And that's going to be at that offset that we figured with nth times how wide things are. See, right there. We're going to start, that's going to be our X starting position. Our Y starting position is going to be the ground floor, the elements value times its level. So if I'm on, everything is set to 0 here because the ground floor is our height, and we're subtracting the quantity of 0 times level, so that's going to be a 0 value. So our ground floor is the height of the canvas, or 0 subtracted from it. Our second X value is going to be how wide our tower is plus the offset value. And then our second Y value is going to be just like our first, but we're going to step away from it by the width of a brick, and we're going to put a little corner on that brick. So that's our large tower wide rectangle, and most of our rectangles are going to kind of go along this ridiculousness here. We have all of this stuff in, because this is what being versatile and robust is all about, where you hardly have any regular values, hard-coded values. Most of all your values are variables. So I have a condition here that tests for our offset or not. So we're looking at the floor. If we're on an odd floor, we're doing this. If we're on an even floor, we're doing that. So flush on even floors, kicked off a half brick to the right on odd floors. Let's loop through the bricks. As we loop through our bricks, we're going from our 0 or our half a brick's width to however wide our tower is, minus at least 1 brick's width. And then we're going to increment by a brick's width each time. And what this does is it gives us our value where we need to drop our brick at. We're going to increment our element counter, what's counting which element we're on. We're going to increment it by 1. So if we start out on -1, now we're at 0. Let's fill this brick with its custom shade, and then let's make the rectangle for this brick. And we're using the offset, and since we've factored in where that brick needs to go by that loop value, we just add it to our x. So we have our offset, we're adding that loop value to x, and we're doing that for both the beginning and the ending coordinates for this rectangle. And it's going at the ground floor minus whatever level we're on. And then we want to add to the x value, the width of a brick. And then we want to subtract from our position, our y position, the width of a brick. And then we want to put the corners of that brick at our custom value, which is held here in this array. So that's all the stuff that goes in. Can you see all the stuff that goes in here? We take this down. So this is our beginning x, this is our starting x, this is our starting y, our ending x, our ending y, and then our how to draw it. Let's do the battlements. So we're just looping through however wide our tower is, and we're subtracting from it one brick's width. We're starting at 0 and we're going through basically 0 to 8. And then we're going to add to it the offset, or the multiple of the offset. This is going to make the spaces between the battlements. So we're making a battlement, we're moving over a whole brick's width plus a half a brick's width to get to our next battlement position. We're going to do that all the way over to the edge of the tower. And that should make them flush. There's how we're shading them. I'm just going to use the color, the custom color from the first element in our color array. And then let's just draw this rectangle. We're doing it just like a brick, but except for the y value, the second y value gets an additional subtraction, which is a multiple of how wide a brick is. So it's basically 2.5 bricks tall. And then these last 4 values here control the corners. So it's flat on bottom where it connects with the castle, and then at the top it's kind of rounded. So now we're done making the battlements. We have all of the lookouts. I'm just trying to think, what are they called? Windows. Lookouts. I'm going to start at lookout number 0, and I'm going to make the door there. So that's what this is going to do. It's going to fill the door color. It's going to fill the door stroke. It's going to fix the stroke weight of the door to 25%. And that's because our door is 2.5 brick widths wide. So I'm staying in proportion there. When I draw the door, I'm doing it kind of like a window, except for I'm going to use that first lookout value. So this dot lookout x, this dot lookout y. Remember, that's a vector we assigned or created up there in the make part. Now we can use its x and y. And if we use element number 0 or index number 0, then we're just using that first ground level. So this value here is 0. It's the ground level. And then this will be this value here is the center of the tower. So it's pretty easy. And we're just going to move up a little bit to make the door so tall, and we're just going to move over a little bit to make the door so wide. So that's what we do there. And then let's curve the top a lot to make it door-like. And the bottom is going to be sharp angles or flat against the ground. See there? All right. When we do the lookouts, pretty much the same here, except for it's not as wide, it's just too wide. And we're using the same x and y, except for instead of using a hard-coded 0, we're putting I there. And that's the loop that we're passing through here, which is the length of our lookout, -1. Color it, give it a black stroke and a gray inside. And the stroke weight is going to be proportional to its width or its height, whichever dimension is greater, I think. And then we put that there. And then we're going to round the top of our windows, not as much as the door, so I'm going to put 5 in there. And then we're going to close out our encapsulation so that we can do whatever graphics or whatever we need to. And at the very end, I have this function here that holds the text there, so you could use that to put whatever you want in there. It just is for this demonstration, for this example that I did that. So that's the meat and potatoes of that. So I'm going to run it again to make sure I didn't mess up anything while I was doing that. And it is still working. So that's our brick tower object, line for line, what it does, how it's made, what you can do to it to change its attributes. You can see the bricks there on the edge cases. You can stylize that, make it look really cool. So what do you think? Did you like this video? Did you learn anything? Did it help you think in reductive terms? How to do procedures, how to relate those procedures to the code that you have to write in order to carry them out? If so, leave me a comment. Let me know what you think. It really helps me figure out where I'm going with these videos, if I'm doing any good or not. I don't get a whole lot of views on these, but I do feel like if anyone's watching them, that they're going to learn something and maybe get some insights into something that they didn't see before. So that's my goal. I hope you've enjoyed this episode. Give me a thumbs up if you have. Subscribe, hit the bell for more. And until next time, as always, take care. The next thing I'm going to do is reset all of these attributes that we can holy crap. Okay, I'm sure you guys heard that, so let's start that line over again.